Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will demonstrate how to certify a single-mode fiber optic link using a fiber OWL 4-bolt optical power meter and a laser OWL series single-mode light source. There are 5 main steps in the process of certifying any fiber optic link. These steps are gathering link information and accessories, checking equipment and accessories for proper operation, entering link information into the certification tester if available, and setting an optical reference, also called zeroing, taking insertion loss measurements and storing test results, and then downloading stored test results to a PC and printing a certification test report. Before beginning any fiber test, the user must gather the necessary link information and accessories required to complete the test. Link information is used to help determine how much loss is acceptable for the fiber under test, otherwise known as a link budget. Optical loss measurements are compared to the link budget to determine if the fiber is good or not, which is the same as saying pass or fail. There are 5 key parameters that apply to any fiber optic test. First is the fiber type, which will be either single mode or multi-mode. In the case of multi-mode, this could be either 62.5 or 50 micron. Next is fiber length. It is important to know how much fiber is in the link under test in order to determine how much loss is acceptable for that particular length of fiber. Some OWL testers can be used to measure the end-to-end length of the fiber automatically, including the fiber OWL 4-bolt optical power meter. Otherwise, the user can use jacket markings, installation documents, or other length measurement methods such as OTDR. For best results, avoid estimating the fiber length whenever possible. Third is number of connections. A connection is the point where 2 fiber connectors mate together, such as in a patch panel, wall plate, or mating sleeve. Fourth is the number of splices, which can be either fusion or mechanical. For the purpose of calculating a link budget, most cabling standards do not distinguish between fusion and mechanical splices. Lastly, the user must determine what wavelengths they will test at. For multi-mode, this is 850 and/or 1300 nanometers, and for single mode, this is 1310 and/or 1550 nanometers. When using a micro OWL or fiber OWL optical power meter, these parameters can be entered directly into the device to calculate the link budget. However, if the link budget needs to be calculated manually, this is done simply by adding together the fiber loss, connection loss, and splice loss. Fiber loss is given in dB per kilometer and varies based on the fiber type and wavelength. To calculate fiber loss, multiply the fiber length in kilometers by the fiber loss. Connection loss is the number of connections multiplied by the dB loss per connection. Splice loss is the number of splices multiplied by the dB loss per splice. Most users will follow the fiber, connection, and splice loss specified in cabling standards, such as the TIA 568. It is also helpful to determine the connector type used in the link under test, which will help determine the right reference cable configuration to use. For accessories, it is highly recommended to keep at least 3 patch cables on hand, since there are 3 reference methods: 1 jumper, 2 jumper, and 3 jumper. Mating sleeves may also be required for some link configurations. Refer to OWL's video on reference methods for more information. Finally, if testing multi-mode fiber, the launch cable attached to the light source will also need to be wrapped around a mandrel according to cabling standards specifications. Refer to OWL's video on mandrels for more information. As you can see, I've gathered all the equipment and accessories required for this procedure. In this case, we're using the fiber OWL 4-bolt optical power meter and the laser OWL series single-mode light source. Now, as you can see, there are 2 ports here, one for 1310, one for 1550. This light source does come in 2 other models, 1310 only or 1550 only. But in this case, we're going to be testing at both wavelengths, which is why we need a reference cable for each of these ports. This 3rd patch cable will stay with the power meter when it does its measurement. There's another reason you need 3 patch cables, and that is for if you want to use the fiber OWL 4-bolt for optical length measurement. So once we've gathered our accessories, we need to check our equipment and make sure the patch cables are good to use for the test. The first thing we need to do is make sure we power on our equipment. On the fiber owl, the power key is right here at the bottom, and then on the laser owl it's right here. And as you can see, you might not be able to see it here, but the 1310 nanometer indicator LED is lit now. So to check our equipment, what we're going to do is we're just going to use the simple meter mode. So we're going to press F2. Okay, now as you can see, the power meter is reading under. This is normal since we have a dust cap covering the detector port here. Once we take this dust cap off, you'll see that some readings will appear on the screen, and this is simply ambient light coming in from the room. This is perfectly normal. So what we want to do is check all three of these patch cables, and we'll check them at 1310 just to make sure that they're good for a quick verification. So remove the dust cap from 1300, and we connect the first cable in to the light source port, and then one to the power meter port. Okay, now the other thing we need to make sure is that we're measuring at 1300. As you can see, it says 850 nanometers here. So we press F3 three times until it says 1310. Okay, now as far as single mode patch cables go, our target value is approximately -10 dBm, but because this is a little bit higher than -10, this is okay. Typically, if you reach -11 or below, this is when you want to consider replacing your patch cables. So we'll consider this patch cable to be good for use. And just disconnect it from the testers here. And then we will do the same for the other two patch cables, as I'll show you here. Okay, as you can see, it's still very close to -10. This is an acceptable cable to use. And finally, the third cable. And look at that, right perfect on -10. So we can be assured that these patch cables are sufficient for use and the equipment is in proper calibration. Once we've verified this, we can begin the setup process. Once the equipment and accessories have been checked over for proper operation, the next step is to set the meter up with the proper link information that we gathered earlier, as well as zero out the equipment using the reference cables. Okay, now in order to do this, we need to be in certification meter. As you can remember, we were in simple meter to do our checking equipment. So by pressing the done key, this will return us to the operating mode screen. Then we use the F1 key to toggle down to certification meter, and then press F2 to select. Now we see the start menu. As you can see, option number 1 is Link Wizard. Link Wizard is simply the setup process by which you're entering your link information. So we're going to press the number 1 here. Okay, the next screen you see here, it says Select Link. Now, when you see the word link in the fiber owl, it simply means a group of fibers that have identical characteristics. So the same fiber type, the same fiber length, same number of connections, and same number of splices. So what we're going to do is we're going to select this first link here, and then it's going to prompt us for a link name. Now this is just a way of meaningfully entering the name of the job you're doing for that day. You don't have to change this name, but it'll make the report a little more meaningful to the customer. For our purpose though, I'm just going to leave it at the default fiber link number 1. So when you're done entering the link names, simply press done. The next screen asks you to enter the date of test. Now this is mandatory. You need to make sure that you enter the right date of test, otherwise it will appear on the report wrong. So in order to do that, we press the F1 key until we until the cursor goes to the beginning of the entry field. And then we enter in the date with the format shown here. So the the month first. And then we need to put separators between all these digits. So we use the 0 key for special characters. Once we've entered the date, we simply press the done key. And then we are asked about fiber standards. There are quite a few different standards to choose from. The default value, the TIA-568, is the one that's used most often in the US. So this is the one we will generally choose most of the time. There are other standards like this ISO standard you see here. There are some Ethernet standards. And there are also some user-definable standards that for advanced users where they can enter in their own their own TIA type link budget. But for now, we're just going to select the TIA standard. So we simply press F2 to select. Okay, the next screen asks you to enter the fiber type. In this case, we are testing a single mode fiber. So we're going to choose indoor single mode. Once we've highlighted indoor single mode, press F2 to select. The next step asks us to enter the fiber length. Now there are two ways of doing this. You can either enter the length manually, in case you already know what the length is. You can look on jacket markings or installation documents or OTDR measurements for the length. However, if you don't know what the length is, then you can use the fiber owl to measure the length. And what I'm going to do is I'll demonstrate the process by which you use the fiber owl to measure the length. Now for this process, we won't need the laser owl single mode source. I'm going to set that aside. But we will need all three of these patch cables, as you will see. So what we're going to do is we're going to simulate a fiber link here. You can see that you have side A and side B. So pretend that you have a closet here and then another closet here. So what we're going to do is we're going to measure the length of this fiber link. So first of all, we take the fiber owl with two patch cables. Obviously, you can see there's two ports here. There's a detector port and a source port, basically a transmit and a receive. We take two patch cables and we plug them into the two ports on top of the fiber owl. So take one like that and take the second one like that. So now we have a patch cable for each of these ports. Then we choose the ports that we want to use in the link. So in this case, let's just use ports 1 and 2. So we connect one fiber in to port 1. And the other fiber into port number 2. Now it doesn't matter which way you plug these in for the length measurement purpose. Okay, now we've connected the fiber all in, we have to loop back at the far end. So we take ports 1 and 2 on the far end. We take our third patch cable and plug it into ports 1 and 2, thereby making a big loop in order to measure the length. So once we've connected in, we press press number 1 to use the meter to measure the length. Now, this screen here basically tells you to do what I just did here. Connect two fibers from the fiber out ports into two ports on the link and then loop it back at the far end. Once you've done that, then you can press the F1 key. And as you can see here, fiber length, there's not very much fiber coiled in here, so we see that there is a fiber length of 0. Now, this length will be different, obviously. It will be based on the length of the actual cable itself. So what we're going to do is we're just going to pretend that there's a number there, like say 100 meters, for example. And we're just going to press F2 to accept this value and input it into the link wizard. The next screen just shows you basically a verification of the length that you're measuring. Coincidentally, if you would have chosen the enter length manually screen, you would have come to this screen here. So what we're going to do is we're going to assume that we're just going to enter the length manually then. So what we're going to do is we're just going to enter the length in here. Now, there are two different ways of entering the length. You can either enter it in meters, or you can press F2 to enter the length in feet. Now, a lot of people like to enter the length in feet because jacket markings on fiber cables are given in feet. So what you can do is if you do have jacket markings, you simply look at the ending and the beginning, take a subtraction, and then enter that number into the fiber awl here. What I'm going to do is I'm just going to assume 325 feet. Okay, so we're entering in feet, as you can see here. So we hit done to enter that value into the link wizard. Now, once we've done with the length measurement, we do not need to have these cables attached anymore. So it's a good idea just to disconnect the cables from the link that you're testing when you're done measuring the length. All right, we're just going to put this aside here quickly. Okay, then we can disconnect from the fiber awl. That's always a good practice to try to put all the dust caps back on whenever possible. Okay. All right. So now that we've got all the ports covered back up, we go back to the fiber awl here, and we see that it says inline connections. Okay, an inline connection is simply a patch panel or a wall plate or a mating sleeve, somewhere where two connections or where two fiber tips are coming together. We can go back to our patch panel here. So let's say, pretend this is a patch panel. Well, this port right here is a connection. There is a fiber coming in the back side of this adapter and one that will be coming into the front. That is what is meant by a connection. So what you're doing is you're counting how many connections you have in your link from end to end. And you do include the two on the end. So most of the time you will have two connections. You'll have a patch panel on either end. So what we're going to do is assume that we have a typical link, and we're just going to enter the number 2 here. Now, specifically with single mode, a lot of times for low loss connections and high quality end face polishes, factory polishes, a lot of times technicians will fusion splice pigtails onto the end of installed fiber. This is probably the best practice for single mode fibers. So what we're going to do is we're going to assume that we did that, and we're going to press the number 2 here because we have a splice, a pigtailed splice on both ends of the fiber. So once we've entered the number 2, we simply hit done, and we come up with a review screen. As you can see, it shows us our fiber standard, our fiber length. Coincidentally, 325 feet is 100 meters. 2 connections, 2 splices, indoor single mode. This is all correct, so we're going to press F1. If it was not correct, you'd press F3 to return to the beginning. So press F1 to continue. Okay, now what you see here is a set source references screen. This is the second main step of the setup process. We will need the laser owl single mode source at this point now. Okay, so now just a little bit about the screen here. You'll see an asterisk here. That's the selected wavelength. You'll see the wavelength numbers here in this column. You'll see the reference in dBm here in the center column. You can see right now this is not set because we haven't set them yet. And a typical value of what your reference level should be. Okay, again, this is just a guideline. It could be a little higher, a little lower, but it just should be fairly close. Now, what we're going to do today is we're going to set a reference for both wavelengths. Okay, which this is the reason why we need 2 reference cables here, one for each of these ports. Now, we do have models of the laser owl that have 1310 only or 1550 only. In that case, you would use only 1 reference cable. Or if you have this laser owl, but you only want to store one wavelength, you would simply use 1 reference cable. But again, for our purpose here, we're going to test 2. This third patch cable will stay with the power meter when we are taking our measurements. So we can kind of set that one aside and forget about it for now. So first thing we do is we connect our reference cables into the Laser Owl single mode ports here. All right, so we have a 1310 nanometer reference cable. Let's make sure it clicks in good. And then we have a reference cable for the 1550 port. Okay. Okay. Once we've made this connection and set a reference, we do not want to disturb the connection to these light sources here. Otherwise, we would have to read zero out. We have to run the process over again. Okay. First of all, what we're going to do is we're going to set a reference for 1310. Now, as you can see, the asterisk here is in front of 1550, so we press F1 to switch. Okay. Now, once we have the selected wavelength, we simply press F2 to begin the set reference procedure. Okay, the first screen you see here, it says connect 1310 nanometer source. So what we do is we find the 1310 nanometer reference cable and we plug it into the detector port on the fiber owl, which is the left-hand side here. You can see it says detector there. I don't know if you can see it, but it says detector. So we plug into that port. Okay. Now we have the connection for 1310. We have to also make sure that our 1310 nanometer indicator LED is lit over here. So once we have verified the connection here, we simply press F1 for done. And then just a fail-safe saying, are you sure you want to set 1310? Maybe you forgot to switch the wavelength. So this is just a gentle warning here. So once we've verified our connection, we press F1 to set the reference. As you can see, it says minus 9.95. It's pretty close to minus 10. This is almost right on. This is an acceptable reference value. So we're done setting a reference for 1310. We'll take the reference cable out, and then we will connect in the 1550 nanometer reference cable. All right. Plug that in here. Okay. Now, what we have to do is make sure we set both pieces of equipment to 1550. So F1 to switch the asterisk, and then the lambda button here to switch over to the 1550. Now, as you can see, if you notice, the indicator LED flashed briefly. This happens when you switch wavelengths. This is the reason why this next screen here, press F2, why this next screen says the source must be in continuous wave or CW mode. LED must not be blinking. That's what this warning is referring to. This LED cannot be blinking. So we know it's on solid, so we're ready to take a reference. Simply press F1 for done, and then again to set the reference. Okay, and again you can see we have a reference value of minus 10.13 for 1550. This is also good. So what this means is that we've just verified again that our patch cables are good for use. The equipment is calibrated, and the references now have been set. So this is what we need to do in order to finish up and start taking readings. But in order to do that, we simply need to press F3 to finish the set references screen. And it's going to ask us to begin taking readings for fiber link number 1 in this case. So we press F1 to confirm. And as we can see here, this is a good procedure to follow, is to make sure that the references are indeed set. Now, what you can see here is that it doesn't look like you're 0.23 or 22. But what this means is that the meter is set to 1310, but the light source is set to 1550. What we do is we simply hit F3 to switch the wavelength. And as you can see, now we're actually closer to our reference value. The other thing we would like to do is just double check the 1310. So again, we switch the reference cables, and then switch the wavelength over here. And you can see that we have a value of about 0.1, 0.2. That's usually sufficient for a reference for this value. So in fact, actually, this is not good. I forgot to change the 1310 here. This is a common mistake, by the way, so you have to be really careful. Press F3 to switch back to 1310, and you can see we're at around minus 0.0. So what we've done is we've input all our link parameters into the link, or into the fiber owl. We have set a reference, and we've verified that the reference is sufficient. So the next step is to actually connect to the link and take readings. Okay, now that we've zeroed out our equipment and verified that they're indeed zeroed, what we can do now is connect the fiber owl and the laser owl to the link under test. So what you're going to do is you're going to leave these two reference cables attached to the light source. Remember, we do not want to disturb this connection, either of these connections here. And then we take that to one end, or one side, maybe closet B, and then we take the fiber owl with its reference cable, or I should call it a test cable. It's not a reference cable, but we take this to the other side of the link. This goes in the other closet. So again, I'll use this simulated fiber link here. We've got closet B and closet A. What we need to do first is, once we're at our positions, we need to connect our equipment in to the links that we're going to be testing. Okay. First of all, you can see on the fiber owl here that says fail. This is normal. You're not connected to anything, so this number is going to look something like this. Your loss reading will appear once you connect in your link here. Now, before we continue on, what I'm going to do, well, first let's connect into the link. What we'll do, we'll just connect into link, or fiber number 1, or port number 1, I should say. Okay, and then we do that on both sides. All right, so now that we're connected in, we verify that we've got port 1 on both sides. We verify that we are connected in with, we have the wavelength set correctly. We have 1310 here and 1310 here, so we're good to go on that front. Now, just to give you a little idea of what's on the screen here, this big number is your loss reading. Pass, this leads to either say pass or fail. This is your test result. This number here is your overhead, which I will argue this is more important than loss, since this tells you how close you are to failing. You see your fiber link name here, your fiber ID, and at this point it says new name because you haven't stored any data yet. dB is your measurement units. You have your temperature, your battery life, and your wavelength, and then your menu selections at the bottom here that correspond to your F keys. Now, just a helpful tip, when you're taking measurements with this kit, fiber owl and the laser owl, it's easier from a testing standpoint to test all the ports first at one wavelength. Make sure all the results are stored, and then switch your wavelengths one time, and then test at the second wavelength. So what I'm going to do is I'm going to demonstrate that here. Now, since we've connected in to our link, you can see we have a loss of 0.62. That's a pass. So we're satisfied with this result. We're going to press F2 for store. Okay, since this is the first reading that we're storing for this link, it's going to ask us to enter a fiber name. Now, a fiber name is simply a prefix to a fiber number that the fiber owl appends to it. As you can see, it tells you that a little bit here. Now, you can change the name here, whatever you want it to be. The default value is FBR:. What I'm going to do is I'm just going to leave it at this value for our purpose, but you can change it to whatever you want it to be. Maybe to further name what patch panel that you're connecting into. But once you're entering the fiber name, done entering the fiber name, simply press the done key. And here you see you have a review of your fiber reading. So fiber link number 1, fiber number 1. So you can see there's a prefix and then the automatic number that's appended on by the fiber owl. Indoor single mode, 0.61 dB pass wavelength. At this point, what we can do is press F3 to save the reading. Okay. Once we've tested the first fiber, we simply go on and test the other fibers. And what I'm going to do is I'm going to simulate that. So we go into fiber number 2 on both sides. Sometimes it hasn't. I'm having trouble getting it. Okay. Yeah, you got to make sure you plug them in sufficiently here. Now you can see we have a loss of 0.4 dB. So we're going to store that reading and save. Okay, then we go into fiber number 3 and so on. I'm just going to test these fibers all together here. So, okay, 0.14, store, save. We go into fiber number 4. Okay, store, save. And we go into fiber number 5. All right, and we store and save. And as you can see, this number keeps incrementing here. So it's basically what the fiberall is doing is prompting you to plug into the next fiber. So finally, we get to the end here, fiber number 6. Okay, and now we have a slightly higher loss here. Who knows why that's happening, but it's still passing. So what we do is store and then save. So now we have all of our readings stored at 1310 nanometers. But we need to store at 2 wavelengths this time. So what we're going to do is we're going to take the fiberall, we're going to plug it back into fiber number 1. And then we're going to take the 1310 reference cable, and we're not using it anymore, so we'll put the dust cap back on. But then we plug in the 1550 reference cable to port number 1. And then we change the wavelength here by pressing the wavelength button. Now, if you notice, your fiberall still says 1310, so we also need to press F3 to change the wavelength. And we have the actual loss reading. Now, one thing that's interesting to note here is that notice that the fiber number went back to fiber number 1. This is because we were testing at the second wavelength. The fiberall automatically assumes that you are testing the same sequence of ports 1 through 6 here. So it puts you back at fiber number 1. So again, we just store all our readings. So store, save, connect to number 2, store, save. See, fiber number 3, store, save. And I'm just speeding up this process for demonstration purposes. Normally what you're going to be doing is you're going to be cleaning and inspecting every one of these connections. So store, save. We go to fiber number 5. All right, store, save. Let me plug into the final fiber, number 6. Store, save. Okay, now as you can see, they all pass. So this is a good link. Okay, so now that we've stored all of our readings, we can basically disconnect all of our equipment. We won't need the reference cables anymore. And then we can do our finalizing work on the ports here and replace all the dust caps and whatnot. But once you have all the readings stored in the fiberall, now it's time to take the fiberall, connect it to the PC, and download the test results to produce a certification report. Once data has been stored in the optical power meter, Test results can be downloaded to a PC to produce a certification test report. First, install the USB driver and OWL reporter software from the supplied CD or a USB flash drive. Connect the power meter to the PC using the supplied USB cable. And then power on the power meter. Then start the OWL reporter program. The program shortcut can be found in the Start menu. When the software has started, the screen will initially say no data loaded as shown here. Download the test results to the PC by pressing either the download menu option or the download button. While downloading, the status bar will say searching for OWL device. Once the test results have successfully been downloaded, the data will appear in the OWL reporter screen. The test results can be viewed in two different formats. This view is called Circuit Detail View. It shows detailed information about a single fiber run. The other view is called Circuit Summary View. Circuit Summary View shows basic information about a group of related fiber runs. Certain buttons become active when Summary View is selected. Pass-Fail, Overhead, which shows how close the test is to its fail point, or Optical Loss. Toggle between Summary and Detail View by pressing this arrow button. Test results can be printed from the File menu or Printer button. The printout will show test results based on the currently selected view. The reports are formatted to look like the OWL reporter screen. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos, or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.